2 and 3 are pretty straightforward. But what I will say, and I will remind you of, is this gives you the 11th term and the 23rd term. So how do we find the A sub 100 in the explicit formula without A sub 1? Okay? We have to go back and do that first. So remember my different version of this formula. So here's what you will be given for an arithmetic sequence. But how did I change this so that it could be more useful, that you should be prepared to have to do tomorrow? Isaiah? Well, you're on the right track. The ones need to be replaced with K's so that this isn't just limited to the first term. So just replace your ones with K's. Now, this can be your A sub n section. So A sub n is negative 19 and n is the 23rd term. This can be your K's. So A sub k, the kth term, is 5, where k is 11. So now, with that information, we can plug in A sub n is negative 19 equals A sub k is 5 plus n minus k is 23 minus 11. That's going to help you find D. Subtract 5, you're going to get negative 24 equals 12D, so D equals negative 2. Okay? Now that you know D, now we can go back to the original version and find the first term. A sub n is still 23. A sub 1 we're looking for. N is 23. No. Oh, A sub n was not 23. I'm sorry. A sub n was negative 19. N was 23. Minus 1. And our D we now know is negative 2. And so we can solve for A sub 1 here by 23 minus 1 is 22. 22 times negative 2 is negative 44. So add 44 to both sides, and A sub 1 will equal 25. So with those two pieces of information, now I can find the 100th term. Nate. To find the 100th term? I would have been missing the 100th term and the common difference, though. Or you mean once I find the common difference? Yeah, you could. You could. You definitely could. Sometimes, a lot of times, they'll ask you to write the explicit formula, though. So I like to just find the complete. But you could have. He's right. You could have just done that. But I'm going to use A sub 1 now. So A sub 100 equals A sub 1, which is 25, plus n minus 1, we're on the 100th term, times my common difference of negative 2. So that would find you the 100th term. And then did I write this in by hand? I added this B yesterday. Did I have you do that? Okay. So the difference between A and B, A is find the 100th term. That's a sequence formula. Find S sub 100 means the sum of all of the first 100 terms. So that's the one formula we're not going to be given. That's 100 over 2 equals A sub 1, which is 25. See, we would have to find it eventually anyway, Nate. Plus A sub n. And I just, in part A, found the 100th term to be, oh God, what was it? Negative, this was negative what? 173. So I need that 100th term in order to find the sum through 100 terms. But I really added this so that you could see the difference between what's a sequence question versus what's a series question. Now, the reality is, even if it's a series question, there's a good chance you need to find the sequence information anyway. But if it's just a sequence question, you don't need the series stuff at all. So this gives you negative 7,400, which is obviously quite a bit larger than that. Of course it is, because that's just your 100th term. You have your 99th term to add to that, your 98th term, your 97th term, and so on. The same kind of thing here, but with geometric, where in the geometric sequence formula that you're given this. But this one is asking, or is giving you the 3rd term and the 12th term, which makes this sequence formula not very useful. But if you change your 1's to k's, which you'll have to know to do on your own, you'll be good. So in this case, a sub n, no, it's going to be my k because it's a smaller number. A sub k is 120, which means k is 3 for the 3rd term. And over here, a sub n is 1.2288, and n is your 12th term. So we would do all that, plug all that in, which would allow us to find r, which would allow us to go back here and find a sub 1, which would then allow us to find a sub 5. And then you could be asked for the series through 5 terms. Can you follow that? Okay. So that's fairly straightforward, believe it or not. There's no twist and turn. Those are types of questions you've answered similar ones before. But then we get to something like this, which was on a Regents at one point in time. And again, totally different. But it does remind me of that homework question that we just went over, where they throw variables in there, Nate, so that you can't use your calculator. So you were asking, and this might be an example of one. So if I plug in, write the following in simplest form in terms of x. So this is telling me I need to plug in 2, 3, and 4 for what variable? 2 is going in for I. So that's going to be 2x plus 4 plus, now I have to plug in a 3. So 3x plus 6 plus, then I have to plug in a 4. 4x plus 8. Minus, because that was only the first summation. On the second one, I have to plug in a 0 for I. So what's 2 to the 0 power? 1, so that'll just be 1x minus 3. Plus, plug in a 1, it's going to give me 2x minus 3. Plug in a 2, that's going to give me 4x minus 3. And then it's all algebra. Annoying algebra. I would recommend adding these together first for a total of 9x plus 18 minus, add all these together first for a total of 7x minus 9, and then distribute your negative. So 9x minus 7x is 2x. 18 minus a negative 9 is 27. So they ensure that you know how summation notations work by throwing variables in there. All right, flip to the back. This one is a concept we've discussed, but not written this way. So they're giving us an 8th term and a 10th term of a sequence. So 64 is your 8th term. Then there's some 9th term, and then your 10th term is 100. They're telling you that the sequence has to be arithmetic or geometric. And so if that's the case, 3 of these are possibilities and 1 is not. Okay? And the wrinkle and the twist that we've kind of talked about in a different context is going to come in when we get to the geometric. But let's just think about if this is arithmetic for a second. I'm going to add D to get to the 9th term, and I'm going to add D again to get me to the 100th. So I'm essentially going to have 64. I'm going to add 2 D's. I'm going to add the common difference twice. and that will get me to 100. Agreed? So D is going to equal 18. So if D is 18, what would that term be? $82. Okay? So 82 is a possibility. So it could be that. If it's arithmetic, the answer would be 82. Now, I could have called this a sub 8 and this a sub 10, and I could have gone back and used this formula and found D and then searched for a sub 10. I could have done all that. I just found that since these two terms were so darn close to each other, it was just easier to do it that way. Okay? That is really the logic behind what your formula does anyway, but nonetheless. Okay. Then if it's geometric, I'm going to multiply by r to get something, which I don't know, and then multiply by that same r again to get to 100. So 64 times r again is supposed to get me to 100. So that's 64r squared is supposed to get me to 100. So if I divide by 64, I'll just leave it 100 over 64. And then square root both sides, what does r equal? (10 over 8), which as a decimal will reduces to 5 over 4. Which as a decimal is 1.25, right? But you forgot the most important part about solving a quadratic when you take the square root of both sides. Plus or minus, okay? It's clear to us that these are positive terms, but if you were multiplying by a negative number, this would be a negative number, and then you'd multiply by your rate, which is a negative number again, and a negative times that negative would get you back to a positive. So it's possible that the rate is positive 1.25, which would make that middle term 80. And then watch, I multiply by 1.25 again, it gets me to the 100. Or it's possible that r is negative 1.25, which would get me a middle term of negative 80, because if I multiply that by negative 1.25 one more time, it'll still get me to 100, because the double negative. Do you follow? So 80 and negative 80 are options if it's geometric. So the only one that's not possible is 1. Tricky, yeah? And then this number 6 was a question on Regents. It was like a 4 or a 6-point question. So this Elena, our good friend Elena, is deciding to run the Buffalo. Buffalo got a shout out on the Regents. Half marathon in May. You know how many miles that is? Half marathon? 13.1. Good. She researched training plans on the internet and is looking. Have you ever seen that? Internet capitalized? What do your English teachers say about that? Do they make you capitalize the word internet? I wouldn't think so. It's kind of weird. And is looking at 2 possible plans. Jillian's is the one that's a dotted plan. Jillian's 12-week training plan and John's 14-week plan. The number of miles run per week for each plan is plotted below. So A sub 1 for Jillian is 10. A sub 1 for Josh is 21. That seems excessive. Why would Josh train for a half marathon by running in the entire week? Never mind. That's 3 miles per day. That's okay. Okay. Which one of the plan follows an arithmetic pattern? Why? He's saying this one. What's your logic? Right. Adding 1 to 11 the second week. Adding 1 more the third week to 12. Adding 1, adding 1, adding 1. This guy is adding 1, subtracting 1, adding 1, adding another 1, subtracting 1. So he's got a pattern. It's just not arithmetic. What's another way you could tell, Nathan? Right, even easier than that, arithmetic means linear. That's a line. This is not a line. That's a crazy thing. So you could say Jillian's, because it's increasing by a constant 1 mile per week. That's what Isaiah said, essentially. Or arithmetic, because Jillian's pattern is linear. Both perfectly fine. Write a recursive definition to represent the number of miles run each week for the duration of the plan you chose. Well, we chose Jillian's. So Jillian's recursive definition. Go ahead and take a stab at that for me, Kaylee. Kaylee McAdam, sorry. What would the arithmetic formula look like? Okay, I'm glad you said that. So there's some confusion, at least for one person, probably more. You're probably not the only one. Up on the board here, we have 4 formulas. In red are your sequence. A sub n. Arithmetic D bar. Okay. Sequence uses A sub n. Series uses capital S sub n. Arithmetic, geometric, and non-geometric uses DR, and the arithmetic uses numeric n. Okay? Someone else asked me yesterday, do we need to memorize the recursive formula? And I was a little taken aback because I guess to me that doesn't seem like an extra memorization, but to him it is. So I guess the answer is yes. You do need to know how to write a recursive formula. It's the same every time, although in a different color. And recursive formulas really are sequence formulas. Recursive formulas are nothing to do with series. Okay? Recursive formulas you can write for arithmetic. You can write arithmetic recursive. You could write a geometric recursive sequence. Or you could write any other recursive sequence. It doesn't necessarily fall into the category of arithmetic or geometric. But these are the explicit. Arithmetic is always a 2-part process. You get to your end term by taking the term before and doing something to it. So that would be a big question mark. You have to see the pattern. Is the pattern adding the same thing every time? If so, you would write plus whatever, which there would also be an explicit version of that, because that would be arithmetic. If it's multiplying by the same thing every time, you would just put times 5 or times whatever. And that would be geometric because there's another version of that as well. But you could also take the term before and multiply it by something and add something else to it, which would not qualify as either of these. And so this would, doesn't have to fall in one of these categories, although it often can. These are explicit formulas. We can only do explicit ones for arithmetic or geometric. The non-arithmetic geometric ones can only be written recursively for what we're supposed to be capable of. Okay, and the second part of the recursive is that you have to give some term number, a sub 1 equals, whatever it is, 10. I think. I like what you first said. Honestly, I think recursives are pretty much useless as far as in real life, because in real life we want to look at patterns, and the point of a pattern is to make predictions that are way, way off. And to have to go through, if you can't put the 100th term in recursive without doing 1 through 99, you have to work your way up to that. Yes, but I think honestly recursive, it comes up a lot in math So, anyway, that brings me back, I guess, to Kaylee. So when you asked, so is that the series one, or you're just a little confused? Recursive will never be series. Recursive is about the sequence. So you've got explicits and you've got recursives. See how they use the A sub n term? They're a sequence kind of option. You will not have to do a series with a recursive sequence unless you first take that recursive sequence and can turn it into an explicit if it falls into either being arithmetic or geometric. If it doesn't fall into one of those two categories, you can't do a series. You won't be asked to do a series with it because those formulas for series will not apply. Okay. So did you write something? So what'd you write? But you're writing an explicit. It's not asking you to write an explicit. It's asking you to write a recursive. So all you need to write is to get to the nth term, we're taking the term before and doing what to it? Adding 1. If they had asked for an explicit, then you would go use that upper formula. Good? All right. Then another scenario. Same question. Jillian's plan has an alternative if Elena wanted to train instead for a full 26-mile marathon. Week 1 would start at 13. A sub 1, 13. And follow the same pattern for the half marathon, but it would continue for 14 weeks. So the common difference is still 1, but the training program is for 14 weeks, so n equals 14 weeks, as opposed to up here, it looked like Jillian's was only 12. Now it's asking you to write an explicit formula. So now we're going to the a sub n equals a sub 1, which was 13, plus n minus 1 times common difference of 1. In simplest form means we just have to distribute and combine like terms. So distributing the 1 doesn't really do anything, and we get n plus 12. And that will be more useful if we're asked, like, well, what do we do during the 14th week then? Well, for this, if you have explicit, you just plug in 14. 14 plus 12 is 26. Versus this one, if we had to use this to find the 14th week, the 14th week would be the 13th week plus 1. Well, we don't know the 13th week, so we'd have to find the 13th week, which would require the 12th week, and so on and so forth back to the 1. Who just had a hand up? I saw one. Okay. All right, so reading is critical, really from now till the end of the year with this sort of tricky stuff. A lot of word problems, a lot of wrapping your head around what's going on. One more final thought before I send you on your way. On number 9 on last night's homework, they give us this concert hall so that each row has 5 more seats than the row in front of it. So that 5 more seats tells you arithmetic, yes? Common difference of 5. So now we know we're in the arithmetic. Second question is series or sequence. If the first row contains 15, how many seats does the 30th row contain? Is that a sequence or a series question? Sequence. What would they be asking? What would they ask if it was good if they wanted to turn it into a series question? Good, Nate. How many seats are in the whole concert hall? Then you would have to add up seats 1 through 30, or rows 1 through 30. So a subtle difference in how many seats does the 30th row contain. They're just focusing on the 30th term. That's a sequence question. If they ask you how many seats are in the whole concert hall, you have to gather from that on your own that that's a series question at sub 30. Yes? I did have a second quiz this chapter on series that I decided not to give you. So what I want you to do for homework is I'll Nate. Oh, Lordy.
This is the test report.
Okay. Thank you. How was the SAT class last night? Right, I know. Right. Right. Good. Open responses?
Yeah.
Oh, but it's either right or wrong. Right. Oh shoot, am I still recording?